Hello everyone, I think it's time to start for the sake of we have to do you think we need more for that?
Yes, I think we've got a couple of stray students coming in.
Yeah.
We'll try to give your 5 minutes. So
Okay.
let's go ahead and get started.
Yeah. Thanks for coming this last presentation or demo for today. And we are now in different buildings, even though the online persons may not understand how far it's up there. So anyhow, welcome. And this demo is based on what Suyang has presented in the morning about human autonomy teaming, especially with cognitive state incorporated, so human in the loop type of systems and demo. Go to the next slide. And this is we prepared all across the 3 different demos that where we are and what we are contributing to. This project composed of 4 thrust areas, and this specific presentation demo is contributing to the thrust 1 computer cognitive models, and then the cognitive control. And as Suyang again presented in the morning, this is the computational framework for the function allocation, which can adapt to changing environment and then the response to human behaviors and cognitive states, human input. So it's interactive. The objective is how a certain task across the team members can be assigned and who does what and when. That is the major goal. And again, adapting to the environments and then adapting to the human's behavioral and cognitive state. For specifically, for this meeting, the presentation, what I mean by cognitive state is workload. And then contributing the cognitive modeling is basically workload modeling. And we are doing the real-time workload estimation using the will show you always where, anywhere. And then the 2 computers using the laptop cameras for eye tracking and then face recognition. And then the feedback capability here, feedback means that our team, the human autonomy team, is heterogeneous. We have humans who have autonomous vehicles, flying vehicle, ground vehicle in these specific scenarios, and then the autonomous systems, and then humans' behaviors are originally designed by this function allocator based on the information obtained up to the current time, initial time step. And then we collect the information over the time online, and then humans react to it and systems react to it. Then adaptively, ultimately, we will decide who does what. And then Suyang will take it over and then give a more detailed tutorial, and then we will start.
Thank you, Professor Ma. So before we get started, we came, let me introduce myself, Suyang here. And they're the processing part. And our motivation in this framework is that we are working on this search execution mostly, and something like wildfire or video blast. And then recently, many people trying to use UAVs or UZVs such that you can make a team of robots and human cooperative search and rescue in a disaster response environment. And typically, this environment is very complex, so we need to confirm many things and transfer survivor to hospital, and adaptively allocating many functions to optimize our performance and also satisfy the interdependent constraints. And our challenge here is that human autonomy teaming can become computationally intractable if we are relying on experimental method or heuristic method. So we are trying to make a formal frameworks and then make things more large. We can try to account for more large and heterogeneous system, and based on our understanding of how humans can change with respect to time and with respect to their cognitive states. And such as estimation, here we have N drones, M ground vehicles, and L humans. And this is a simulation work of these simulations. You see 2 people are sitting here, like them. And then in the base, drones navigate and scan the assigned region, dotted by the red ones. And the ground vehicle transports survivor from search area if something found. And then humans verify scanned images, perform survivor triage, monitoring air traffic, and set priority. And you can see that some green hollow is coming here. It means people are thinking something. So I'm presenting this kind of symbolic function here. And you can see that this environment, there are some obstacles that should be avoided by non-vehicles, gray ones, and no fly zone by drones here. And you can see that base is here and hospital is here. And when you see this working scenario here, drone search the area, scan the area, and once some survival is finding, then ground vehicle should be assigned here and then go to the hospital. And during that, human need to do many different symbolic functions, which we will show during this thing. And our objective is can be decomposed in three things. First thing is try to make a formal representation of large-scale HAT scenarios. Especially, we are working on hierarchical structure for flexibilities and scalabilities. And also, we are working on cognitive engineering plus robotics, merging them to make a leverage both of them in computational tractable framework. And second thing is we are trying to make an adaptive functional location. So now we are not just assuming something is just stand still. We always think about something changed, something can be degraded, some human can be overloaded. Then what would be the next? And then human-centered approach is that now I'm wearing this portrait sensor, and they have some cameras here. So we are going to use a camera and portrait sensor to measure their workload in real time and adaptively make a functional location. So yeah, this slide is coming from the previous one, so I will go very briefly here. So we have robotics and cognitive engineering have insightful findings here. But now we are trying to go one more further major step here, try to make a HAT, challenge the HAT challenges in interdependence or locations, along with different capabilities from humans and robots. And then, yeah, this is our framework based on the reinforcement learning. And then formality, scalability, and human-centered approach is our thing. And here is the how workload estimator is worked. So this part was missing during the morning session. So currently, I'm wearing this pull-out and portrait sensor, and they have this camera in here. So you can see that some gaze data, my eye gaze is me, and then my feature is eye roll and mouse. Maybe my emotion can be revealed here, frustration or something like that. So this information is going through. And then you can see also there is a heart rate sensor here. So heart rate signal, ECG signal, the electronic signal is flowing here. So we gather ECG, gaze, and other feature means face features, facial features. Will be transformed into our transformer encoder. And then as a result of that, we will have a kind of real-time workload meter here from 0 to 1. So 0 means absolutely low workload, not very often. It's usually low. 1 is kind of high workload experience. So our demo configuration physically, this is what you're seeing is main GUI. So I will print off main GUI here. And you see individual GUI here, human 0, human 1 here. And each of them have camera and portrait sensor. And from the individual GUI, they will make some decisions. And they are portrait and they using portrait camera, they will estimate their own workload. And that information will flow into this main. And then main GUI simulate the whole system, so that has simulation engine. And function will be allocated, and then simulated environment and allocate function will propagate to each other. And then this is cyclic works. So this is the framework based on the solution. Let me explain which function can be assigned to who. So basically, obviously, search and scan can be done only by drone. Human cannot go there. That's the one we use really. And only human can allow to make a final decision about the scan it. So confirm it is survivor or not. And then only ground vehicle can pick up and drop people. And this is tricky part, so we allow the human and drones can do these things simultaneously. So it's a monitoring and response activities here. So when fire is coming, then set priority. And when survival sends some message, make a triage. And if error traffic message is there, then make some confirmation, something like that. So this is main GUI we have here. And you can see that here, 5 drones are flying around this area. And let me go through step by step. No worries about very complex video here. And then these blue dots are kind of our legend to search and rescue. And you can see that once drones flying to the target 2, then it's going around and search the area and scan the area. And then once human confirm that there is a something. Here we can set the product here. Yeah. And this kind of specific task will be explained in detail. And once the human some image is found, then human can confirm this one or reject this one. Yeah. So since this is too complex to explain in this way, we'll go through some smaller. So our timetable is that first I just finished our presentation, and I will go through some simple scenario with small number of persons, small number of agents, and then go with main scenario, and we go to the discussion. Okay, so while we are preparing this one, I can take some questions if you have it.
Is the workload that you're monitoring being used to trigger any kind of autonomous behavior or task shifting allocation or anything like that?
Yeah, workload.
Yeah, I can answer. Yes, function allocation takes that as an input, that a specific human operator is overloaded, then the task will be taken out and then distributed to other agents.
To other teammates? That
Yes, teammates, sometimes they even
How do you estimate the accuracy of the workload?
That's a good point. The Juman, you probably answered that question.
Currently, we try to train using a kind of supervised learning scheme. So we collect the data, we intentionally make the participants being overloaded. And we collect the data while we just let the human focus on the train mission. So we use that as a kind of absolute label and train the network.
Yeah, so basically we use the supervised learning, means that we know the answer, the estimation is correct. and
I'm
correct.
interested in how you get the label.
How we get the label?
Yeah, so we intentionally make.
We can, you guys can talk after things, yeah. But very good question.
So for online talks, you may have 4 tasks here. First one is main, presentation, and main UI. And you may have 2 individual tasks, H0 and H1. And you may have loom camera that you can see all of the critical configuration of this one. So feel free to choose any task for your convenience, but I will explain it main and H0 for now. So let me explain. If you can see H0 now, you will see this individual GUI here. So first part in the left top part is workload estimator. So you see the work meter here. Partial sensor is coming through here. This is real-time data. And then this part is verification part. So some images will pop up here. So human can accept this one, reject this one. And then next part is survival triage, left bottom here. So you will see 3 symptoms of the survivor, and you can determine it is emergency or delayed or minimal. And here is the error traffic message, and you can confirm some message by typing something here. And this is task list, so you can set priority based on the current situation. I will show you here.
So here, in this case, I will get a new task to set the priority region number 8, show me the main screen. So once I change the priority at region.
Yeah. So since this operator decided that this 8 is higher priority with this red dot, now go and search this area first.
And here in the search reason, I get to receive a image whether there's a survivor or not. But I cannot find any human in this image, so I cannot deny this guys here. And but in this case, it seems there's a human, so I cannot accept this image.
Since that image is accepted by this human operator, now ground vehicle is heading to the best positions. And if you see this area, you can see this white foggy area. That means some new information is coming in, and it will darker again after time goes on. So now since another big tip, a survivor image was accepted, so now another ground vehicle is heading to there.
And here I now get a kind of triage task. So Here's a brief description about the participant survivor status. And based on this information, I choose whether it's an emergency survivor or somebody can still survive for a while.
And you can see that ground vehicle just touched this hospital and is going back to the base basically. But if there is some more images, then the ground vehicle can change the wheels. Yeah, since this area wants survivor again, then ground vehicle is assigned again.
And in this case, I got an ATM test. You can see that there's an ATM reference on that region that where the string is currently indicating through the mouse.
So since this confirmation and message is coming to the air traffic, then this blue area is disappeared.
I must be really nervous. The workload is ticking high.
Higher than
This is the first time he is doing this many equipment.
Yeah, no pressure.
Roll one. My body is
Look at that.
Why are doing that? Let me introduce this part briefly here. So here drone conditions are the position, latency, and what task is doing scan 10, which means this drone is scanning this 10 area, so you can see the real time. And this ground vehicle now kind of trying to drop off here. And then since another ground vehicle is just stand still, so you can see the idle here. And human utilization is kind of sliding window-based level of business, of the level of utilization of the human within 1 minute. So 22% means he only spent 22 seconds during the last 1 minute to do something. Okay, and that's pretty much it.
There's a question here.
So the chest band that you're wearing, is it feeding into anything?
Oh, no. This is just for showing off. Yeah, because they are wearing under the shirt.
We're wearing under the shirt.
Okay.
I cannot show you, so.
Okay, that's
Yeah, I'm the only one who can show you.
So Juwan has.
Yes.
He's wearing.
Yeah.
Okay.
And yeah, I will explain this one, but we have the automated results screen here. And you can see that task completion score over time is once Junon completed some task, I give some score based on some weighted sum. And then that goes up here. And then we can see the mission completion time was 219 seconds. And human utilization time over means sliding windows of how much level of business during the time. And you can see the Junon was very busy during this time. So basically, during this time, for all one minute, he's supposed to do something. So yeah, he was very busy. But as mission is going down, yeah, it's going down again. And this part is kind of how many tasks are assigned or completed with respect to time. It is very clearly shown here. And this is one of the most interesting part at the bottom side. X-axis is time, second, and Y-axis is agent. Drone 1, drone 2, ground vehicle 1, ground vehicle 2, and human 1. And you can see that this colored region present what functions have been done by each agent. So you can see that drones are doing navigation scan, something like this. And then ground vehicle, basically pick up, drop, something like this. And then human are doing 4 different things. Set priority is brown, purple, verify the image, doing purple triage, pink, and mint, confirm ATM message. So based on that, you can analyze what have been done computationally, and you can think about how can we improve the functional location. Now it's time to move on. This time we are ready to move on to the full-scale demonstration. Not full scale, but the biggest scale we can use in this limited screen.
So we can increase the number of agents arbitrarily. It's not arbitrarily large enough, but it's too messy. So we start certain numbers here. We think it's reasonable balance between the complex and then the individual.
So now key point is that the number of agents, number of robots, and the number of regions should be increased, and we will have both of them to participate here. So important thing is that some function will be allocated not only between humans, but also between humans and drones.
And just for your information, you can see this green line here. This is directly affected by my C sensor right now in real time. This is actually my working.
It's not mine, so. It's not mine.
So basically, it's initialized, generating scenario.
Yeah.
So have you already had a baseline to see what your high workload is in this task?
We normally get about around 3.8 to 0.9 for the biggest case. I think I get nervous for that. I've never seen one keep showing like this.
It's already trained for him, but not really stressful.
So now we have a number of storage points here. And now key difference here is that now you have Voronoi area. So we make sure that each area can be divided with these green lines here. And what we are doing is basically the same. But there's many number of robots, and we have 2 humans, so it is very important to allocate the function efficiently.
Now I identify the numbers 2.
Yeah, here, yellow one. So it's a medium level priority here.
I now got a new image from the drone and I reject it.
Rejected, so there's no ground vehicle movement here. So number 8 is priority medium, so now new drone is prioritized this assigned task. And one image is accepted here, so ground vehicle starts to go there.
And I got an explanation that 40 minutes, 30 minutes, point as well.
Message confirmed, so this up here. And while doing that, some interesting point would be some kind of comparing this utilization. So our proposal is to make balance between them. So not to allocate too much function to each individual, but we are trying to make a balance in here. And we will see the final result with our graph, so we will see.
Checking the triage situation. Setting another priority.
Yeah, you can see here, with the red one, the new drones are located here to prioritize this target. And you can listen to this beeping sound. Beeping sound make aware that they have to do something. So they are keep allowing them to notify something, not just visually, but also make a sound here.
So Sian, can I emphasize that your system is intervening based on workload amongst other things to shift tasks, not
Yeah.
just between autonomy and human, but between humans?
Yeah, between human, between autonomy. Oh. And maybe if you remember this one, this H1 was a little bit higher, but now it's a balance. So it's a keep trying to make some balance the way it can. Yeah, and then notice typing something in message here, so this will be disappear.
Reset priority.
Yeah, if is setting priority. So the priority not only drones, but also ground vehicles with relocating. Again, as it's coming in, so this is the first thing.
I just reject another image.
The rejection image means that movement is skipped by ground vehicle, so no ground vehicle will be below. I think scanning is almost done here. another high priority target, so everyone needs to go there for sure.
Responding to any other message.
Here. That is up here again. So to put this priority or ATM message, this human operator should keep monitoring this monitor as well. So that makes it a little bit easier. Human is typing something and once this is confirmed, this will run.
So this is to ensure a situation where it's
Yeah,
confirmation
yes,
of
yes.
a message is received
Yeah.
by the air traffic management.
Yeah, exactly. We try to make sure that these drone pilots or operators are aware of situations. So as an evidence of that, we are just asking them to confirm some messages.
While also being aware of the orbital that it incurs.
Yeah. And then I think we are pretty much on the end phase. So maybe this 14 will be the soon. Let me turn off here to see our final result.
So yeah, is it easy to fix that code over here? Somebody's got an extra obvious.
It was our technical difficulty because we want to play this beeping sound. This is the only. So yeah, we got this figure. Let's go through something more easy to see. So this is exactly the same figure. Yeah, just easier to go into this. So you can see that with the respective time, task completion score is kind of balanced way, but it does not mean this score should be the same because we give some more score for image verifications because we think that is the core. So it may say the human one here, Ifan, may give more human image verification. That can be a reason why he has a higher score here. Then we can, if we want to look into more details, we can use this information for sure. And this is the human utilization over time. And our goal is regulating this human utilization, not going over 80%. So that was our bottom line here. And to be honest, this is not a kind of optimal control, constrained optimal control, because humans are humans and they are not predictable. So even though we say, oh, this is going very well, maybe we can try to do giving less task here, but human may have some delayed response by some reason. And then there is currently there is no way to make a hard constraint here, but at least something happens, then we can do something immediately, try to make this is decreased. And then you can see that this kind of high balanced way, at the first time, human one take more task here, definitely. So Ivan was a little bit more easier than human, functionally. But it changed again, cross and make a similar, here.
So is human utilization just based on the taskings that they have?
Yeah, so it's a different concept of workload and utilization. Utilization, like you said, utilization just based on how many tasks work.
Not how many tasks they completed?
Not completed, how much time they spend their time during the 1 minute to do some task, any task.
So it's time spent on a
Yeah,
specific
yeah.
task. Okay.
Just one time.
And you mentioned this 80% number in your presentation today too. Is that a guideline that is like in the literature that you want to keep utilization below 80% or that was a threshold you specified?
Yeah, so number 80% is really the arbitrary one, but I read that literature that prolonged high utilization can be key for the human performance. So the key point is that that's verification because you can change it 60, 50, whatever you want, basically. So maybe task can be a little bit delayed if we utilize too much. But I think 80% was kind of very good for demonstration, not too slow, not too fast.
Okay.
Yeah, so I just
All right, thank you.
Did you have a task allocation switch right there when we see that human one starts to drop down after the 80% threshold is hit?
Oh yeah, so maybe that is, if we see this one, there's a for example here, maybe this human one was a little bit easier here until now. You can see here, human one, this lower part was a little bit easier. But it is hard to see, but we can see more idle time after that 100 seconds.
I think you also have in the higher areas, one of those little pink ones in your curve, where the UAVs took on a task that would otherwise be assigned to the unit, right?
Yeah, so
We didn't talk about those.
So yes. So if I can answer the country question first, then since human one, this orange one was a little bit easier in terms of utilization at 100 seconds. Now it's giving less task to human one here. More idling gray area is in here. And like Professor Walsh just pointed out, since two human balls suffer quite high utilization, not over 80 here, but very close to 80 for a long period of time. So function allocator may determine after 200 seconds here. Now, not only just a human is doing this four tasks, but now you can see some drones are involved with this green part, brown part and pink part. This brown is set priority, and then this pink is triage. So now drones are kind of hand over some tasks to reduce the human utilizations.
This concept is very similar to what Brandon said in his presentation, the demo presentation, the human available, car available, and so on. But in this case, two humans are not available because they reach the limits with that 80% for a certain period of time. Then drone can do some task with human, and they take over kind of a backup. And then once human get relieved, then they make another decision.
Yeah.
So not only the human workload, the task can be transferred from one to the other, but also some tasks can be shared by the automation too.
So you start with preference, but you adjust as needed.
If I can add one more thing here, we can check. We can put some kind of parameters such as the success rate of the doing triage or set priority by drones, if we want. So we can make some different simulation based on that. And then we can test human user study to make a more trained data. Collectively, we are using this individual data. So we collected particular sensors and image sensor with the facial features to estimate their workload. So that's why we put these two humans today, unfortunately. So if we want to do this one, we may need some training, but also kind of transfer running can be considered in the future.
Another follow-up question. So right here in this region, when the drone did the scan, that was they produced the image, then they took over part of the task of the human to alleviate some of their load. And they set priority, and then what was the pink for?
Pink is triage, so
Analyzing the image and
Yeah,
deciding,
yeah.
like, okay, there is a human here, we need to do something.
yeah, human is in emergency situations
Yeah.
or kind of low situations. Something like that.
So is this a correct decision by the UAE?
So, correctly simulated one, we assume that this is correct, but we can change the parameter of that, and we can make a score after all tries. So if say triage is correct for UAV 0.9, and for human, we don't know yet, but we can test it and collect the data.
Yeah.
And we can test it, how functional location should be changed if the capabilities of drone change. For example, drones have less accuracy, then maybe more functional location should be done by human.
Yeah. So you get into an interesting trade-off point where you start seeing, okay, we reallocated to reduce workload on your humans, but then it resulted in long-term,
Yeah.
like, discreditability or
Yeah.
reduced performance for the whole
Yeah,
team.
very good point.
So,
So let's say humans suffer very high utilization for a long time and performance is getting
yeah,
degraded.
Yeah.
And maybe there could be some
yeah.
the crossing point, and maybe it's better to allocate function to drones. And good point about this one is that we can do it automatically,
Yeah.
not by humans.
I think this is the last one. Especially online, do you have any questions on this demo? Thank you.
Awesome.
Yeah, this is if you're interested in special produce students, try. It takes a lot of time to. This is a virtual
Yeah,
communication or
yeah.
That's, yeah, that's it.
I wish for you to
He said no, it's just like-
Okay, so the online folks, we here are going to be heading back to the room that we started this morning, and we will start up again at 3:45, so about 25 minutes.
Back to Dudley. Yeah, back to Dudley. And I will take,
I don't know, I think it's my work
Is it hot?
It's been really hot, so it's really humid.
that much.
Hey,
I remember the summer.
thanks for recording.
You're welcome. Quite welcome.
There's like every time I go walk, I say, it's depressed, and I go walk in, and maybe a day,
No.
nervous again.
Yeah. That was amazing. Big, big, one, eight.